Welcome to the future. You're watching FutureLens. For 70 years, we have lived in the era of the clock. Every computer you have ever touched, from the massive mainframes of the 60s to the smartphone in your pocket, operates on a heartbeat of rigid mathematical logic. We call it the von Neumann architecture. It was brilliant. It built our modern world. But in April 2026, we have finally hit the wall. As our AI models grow more complex, they demand more energy than entire cities can provide. We are trying to force a rock to think like a human by throwing more electricity at it. But the rock is getting too hot, and the logic is getting too slow. The gap between how a computer thinks and how a biological brain processes has become a canyon. But today, that canyon is being bridged. We are moving beyond the binary. We are moving beyond silicon. Welcome to the era of neuromorphic computing. This month, a massive shift occurred in the semiconductor industry. Major tech labs have officially moved from testing to the commercial release of the first Neuromorphic Processing Units, or NPUs. To understand why this is a revolution, you have to understand the flaw in your current PC. In a standard chip, the memory and the processor are separate. They spend all their time and energy screaming data back and forth across a tiny wire. This is the bottleneck. It's inefficient, it's loud, and it's expensive. The new neuromorphic chips don't work like that. They are inspired by the architecture of the human brain. They don't use a constant clock. Instead, they use something called spiking neural networks. Think of it like this. A normal computer is like a faucet that is always running, even if you only need a drop of water. A neuromorphic chip is like a nervous system. It only sends a spike of electricity when there is something to say. No input, no power. The result? An energy efficiency increase of over 1,000 times. The implications for the IT world are staggering. Until now, AI lived in the cloud. Your phone was just a window to a giant server farm in another country. That was because learning required massive power. But these bio-inspired chips change the rules. Because they mimic biological synapses, they can support on-device learning. Imagine a drone that doesn't just follow a pre-programmed path, but actually learns the layout of a room as it flies, without ever connecting to the internet. Imagine a medical wearable that learns your specific heart rhythm and identifies an anomaly in real time because the brain is inside the device itself. This is the end of the cloud's monopoly. We are entering the age of edge intelligence, pure, local, and private. If the code is running on a chip that functions like a brain, the data never has to leave your hand. This is the ultimate technological sovereignty. If you've been watching the humanoid robot industry in 2026, you've noticed a change. The movements are becoming fluid, less robotic, more animal. This is the secret of neuromorphic hardware. Biological movement isn't calculated by a central processor. It's a series of reflexes and spikes. By using these new chips, engineers can now give robots a nervous system. This allows for sensory processing at the speed of thought. A robot can now feel a slip and adjust its grip in microseconds, just like you would. We are moving away from programming machines to move toward training machines to exist in physical space. It's no longer about writing lines of code, it's about architecting the flow of impulses. The barrier between software and biology is thinning. Here at FutureLens, we talk about deep authenticity. We ask, what is real? For years, critics said AI was just statistics, just math on silicon. But when the silicon itself begins to mirror the physical structure of our own neurons, when the computer process begins to pulse with the same spikes of energy found in your own prefrontal cortex, does the distinction between artificial and natural still hold? We are no longer just making tools. We are creating digital vessels that are capable of a form of synthetic intuition. We are building machines that don't just calculate the world, they experience experience, the data. If you are fascinated by this transition into the hybrid future and you want to stay ahead of the curve as we navigate these technological shifts, please like this video and subscribe to the channel. It helps us continue to bring these deep dives into the future to you. The year 2026 will be remembered as the moment the clock stopped and the pulse began. The transition from traditional silicon to neuromorphic architecture isn't just an IT upgrade, it is a fundamental shift in how we perceive intelligence. We are leaving behind the era of the machine and entering the era of the bio-digital. The question is no longer, what can the computer do for us? The question is, what will we become when our computers finally begin to think like us? Thank you for watching FutureLens. Look deeper, question everything, and stay real. I'll see you in the next one.